Hi everyone. In the last section we took a look at finding the area using sine, and in this next section what we're going to be looking at is we're going to be looking at finding the lengths of sides and the measures of angles that are found in non-90 degree triangles, and we're going to be using what we call the sine rule. Now, so again, in the previous section we found the area of the triangle by taking half the product of any two sides and the sine of the included angle. And the formula that we came up with was this right here, which said 1/2 of AB sine of C equals 1/2 of AC sine of B, which equals 1/2 of BC sine of A. Now, because all these above equations are equal to each other, then what we can do is we can equate two of the expressions, or two of the equations at a time, to see the following relationship that comes up with it. So what I've done is I've taken the 1/2 BC, I took 1/2 BC, the sine of A, and I made it equal to 1/2 AC sine of B. Now, in doing that, the 1/2s canceled themselves out, which are the blue lines. The value of C canceled out with the other value of C, and what we're left with is B sine A equals A sine B. So that if I rearrange this equation, then what I end up getting is that I could put sine A over A, and I could make that equal to sine B over B. Now this is one of the following relationships that we see. Now, excuse me. If we were to equate two other equations, so I take 1/2 AB sine of C, and I make that equal to 1/2 AC sine of B, again, I cancel out the 1/2, and I cancel out the variable A and A that is found on both sides of the equation, so that we end up with B sine C equals C sine B. And again, I rearranged the expression in such a way that I said that the sine of C divided by C has to equal the sine of B divided by B. And that's a second relationship that we have going. And then the last one I do is I equate the last two expressions. So I took 1/2 AB sine of C, which equals 1/2 of BC sine of A. And again, I crossed out my A's and I crossed out the 1/2s and the B's, which were common, and I was left with A sine C equals C sine A. Again, rearranging, I ended up getting all the C's on one side, all the A's on the other, so that sine A over A equals sine C over C. So these were three relationships that we had going. Now, the sine rule basically says that taking the three relationships that we found, sine A over A equals sine B over B, which equals sine C over C. This is what we call the sine rule. And what the sine rule basically says is that in any triangle, so not including though right-angled triangles, the ratio of the sines of the angles and their sides is constant. So what that means is that if I were to take the sine of angle A and divide it by its opposite side A, it would have exactly the same ratio as if I had taken the sine of angle B divided by its opposite side. That would have the same ratio as taking the sine of angle C and dividing it by its opposite side, C. Now, so that the ratio of the sines of the angles and their sides is going to be constant, or it's going to be the same. Now, there are two situations in which we find where we were looking for things using the sine rule. Again, always with non-90 degree triangles. Okay, so anything else that's a 90-degree triangle, you would to find lengths of sides and to find measures of angles in a triangle with 90 degrees, we would use SOHCAHTOA. But because we're dealing with non-90 degree triangles, we're going to be using the sine rule, or the next one that we'll be learning in the next class, the cosine rule. Now, there are two situations in which we use the sine rule. We can either find the lengths of sides, or we can find angles. So we're going to find the lengths of sides first, because finding the length of a side is far easier than finding the measure of an angle. Because finding the measure of the angle leads us to what we call an ambiguous case, and we'll be talking about that in a little bit. Okay, so let's take a look at finding the measures of angles, finding the lengths of sides. I apologize. Okay, so what we have here is we've got that we have angle ABC, and angle ABC tells me that if I were to take the sine of angle 113 and I divided that by its opposite side, and the opposite side is going to be little a, okay, that would give me the same ratio, which is why I'm placing the equal sign here, as the sine of 41 degrees divided by 18 meters. Now, in order to be able to find the lengths of sides, you must have two angle measures and the side, making sure, of course, that I have the angle that's opposite the side I'm looking for, and that I have the angle and the side opposite some other angle. Okay, so I have some other angle, and its opposite side has to be the same as the angle here, sine A, or sine of 113 over its opposite side. So all we need to do now is we need to simply move things around so that we will isolate for A, so that I will say that the sine of 41 degrees multiplied by A has to be equal to 18 times the sine of 113 degrees. So now, to isolate for A, I'll just say that A equals 18 times the sine of 113, all divided by the sine of 41 degrees. And so I would take out my calculator, and in using the calculator, I would simply say 18 times the sine of 113, close the brackets, would then be divided by bracket the sine of 41, close the bracket. That wasn't necessary that I put that second bracket around the sine 41, but I did place it. Enter, and I get an answer of 25.3. So I know that the length of side A is going to equal 25.3. Oh, and it did ask for the answer to 2 decimal places, so it's 25.25 or 25.26, because it was 255, so it would be 25.26. Okay. Our next example allows us to, again, find the length of a side, but this time you are not given the actual triangle, but you're going to make your own. And this is where you really show that you understand the material. So that if I make my own triangle, it doesn't matter what it looks like, and I call it triangle A, B, C. Well, we know that side A is the side that I'm looking for, because it says in triangle ABC, find side A. Now we know that angle A equals 65, and we know that angle B equals 35 degrees, and we also know that the length of side B is going to be 18. So because this is angle B, then the opposite side has to be 18 centimeters, because we are given angle B, therefore the side opposite angle B is going to be side B. Now, I'm going to see if I can make a comparison of sine A over A equals sine B over B, which equals sine C over C. So I have the angle, I have this angle and its opposite side, and I have also been given this angle, and I'm looking for its opposite side. So I have 3 out of the 4 terms that are necessary in order to solve for the length of the side. So I can do my ratio comparison here and say, well, the sine of 35 degrees divided by its opposite side, 18, should really have the same ratio as doing the sine of 65 degrees divided by its opposite side. Okay, so all I do now is I rearrange the equation so that I end up getting I would have a sine of 35 is equal to 18 sine of 65. And therefore, I would then divide both sides by sine of 35 by the sine of 35. And using, again, my calculator, I would then say, this would get canceled out. And using my calculator, I would say 18 times the sine of 65, close the parentheses, divided by the sine of 35, close the parentheses, enter, and I end up getting 28.44, so that I get A is equal to 28.44, so it would be to three significant figures, so it would go to 28.4 centimeters. Okay, so that's a situation where I would look for the length of sides. So when we're looking for the length of a side using the sine rule, that means that I must be given two angles and I must have one side. So two angles and one side is definitely obligatory in order to find using the sine rule. So for the sine rule, we need two angles and one side, okay, in order to find a side, to find other side. Okay, so now we're going to get into a part that's a little bit more complicated. So the second part of this is called when we're looking for angles. And when we are using the sine rule to find angle measures, the situation gets a little bit more complicated because there's something that is called the ambiguous case. Now, what the ambiguous case basically tells us is this. Now, if I were to try to place into my calculator right now, and we can do this right now, if I tried to put into my calculator the sine of 30 degrees right now, I would get an answer of 0.5. Now, if I placed in their sine of 150 degrees, I would be getting the same answer. Now, if I tried doing the sine of 20, I would get this answer. And if I did the sine of 160, I would get, oops, I placed in there sine of 60, not sine of 160, so let me just clear that. Okay, so that I would say then that the sine of 20 was that, we just found that, and therefore I would say the sine of 160 should be exactly the same. All right, now let me try one more. What if I did the sine of 35? So the sine of 35 gives me an answer of 0.5735. Now if I did the sine of 145, that should give me exactly the same value. Now, what is it that I found here? This is kind of similar to what we did with the sine of 20 equals the cos of 70, the sine of 50 is equal to the cos of 40, and so forth. So what we're doing is we're saying that the sine of any angle, okay, is going to be equal to the sine of 180 minus that angle. So all I did was I said the sine of 30 equals the sine of 180 minus 30, which is the sine of 150. I said the sine of 20 equals the sine of 160. And another example, again, the sine of 135 is equal to the sine of 45. Okay? So that the numbers, the angle measures added up together have to equal 180. All right, so here are the examples that I just showed you. Sine of 70 equals the sine of 180 minus 70. The sine of 30 equals the sine of 180 minus 30, which equals 150, and so forth. Okay, so now when I'm looking at finding the measures of angles using the sine rule, I need to understand, or I need to be clear on the fact that the sine of the angle, which is a ratio, could really be giving me an obtuse angle, or it could be giving me an acute angle. Now, the answer that we normally get in our calculator is going to be always the acute angle. So, for example, if I had, again, the sine of 30, I know that the sine of 30 gives me 0.5, but if I did the obtuse angle version of it, that would be the sine of 180 minus 30, which makes it sine of 150. And we know that the sine of 150 is identical to the sine of 30 because of this trigonometric identity, which says that the sine of theta is equal to the sine of 180 minus theta. Okay, so let's take a look at trying to figure out the measure of an angle. Now, finding the measure of the angle per se is not that difficult. So I can do, for example, I need to find the measure of angle C here in triangle ABC, and we're told that AC equals 8, AC is equal to 8, AB is equal to 12, and angle B equals 28. So the sine rule, the ratio of the sines that I could use would be the sine of 28 all over 8. So the ratio of the angle given divided by its opposite side has to be exactly the same ratio as the sine of the angle C divided by its opposite side, which is 12. So now I rearrange so that I isolate for sine C, and I get 12 sine of 28 divided by 8 equals the sine of C. Now, because I want to get an angle measure, it's obvious that I have to do an inverse. Okay, so it's going to have to be sine inverse when I look for a measure of an angle. So it's sine inverse, cos inverse, or tan inverse, depending on what formula you're using. So when I multiply 12 sine of 28, which I can do right now, I'll do 12 sine of 28, and then I'll divide that by 8. And I end up getting 0.704. So I have 0.704. 0.704 is equal to the sine of C. Now, to get the angle measure, all I need to do is bring the sine over to the other side. So I do sine inverse of 0.704 approximately, and that'll tell me what the angle measure C is. So now, again, back to my calculator, I will then do the second function, sine or sine inverse, of the number up here. So instead of writing the whole number out, I can just press second function and go to answer. And that's going to put all of these digits in for my answer, so without me having to rewrite them. And I press enter, and I get 44 point, I believe it was 7. So 44.765. All right, so I know that the acute angle here is 44.765 degrees. But if I follow the rule that I said, that sine theta has to equal the sine of 180 minus theta, well, what that means is that I'm going to have to say that the sine of 44.765 has to equal the sine of 180 minus 44.765, so that my angle as an obtuse angle would have to be 180 minus 44.765, and we would end up getting 135, I didn't see the rest of that, 0.235, 135.235. Okay, so I know that my acute angle is definitely going to be 44.765, and then I have the possibility of having also the obtuse angle of 135. So this angle up here could be 44.8 or 44.76, or it could be 135.2 or 235. Now, how do I know if I can accept or if I need to reject the obtuse angle? Well, because the measures the total measures of the angles of a triangle are 180 degrees. If the sum of the two angles in the triangle, so if I took 135.2 degrees and I summed it up with 28 degrees, which is the other angle in triangle ABC, if the sum of those two were to be greater than 180 degrees, then I would have to reject the possibility of the obtuse angle. But since 135.2 plus 28 is going to be less than 180 degrees, then I can accept both the obtuse and acute angles. Okay, so my two solutions then would be, as an acute angle, it would be 44 point, and I'm going to put this to three significant figures now, 44.8 degrees, or my solution could be 135, which is 0.2, so I'll leave it just as 135. Okay, and that's since 135, I've already written this up at the top. Since 135 plus 28 is less than 180, we can accept both the obtuse and acute angles. If the 135 had been added on to another number which made the sum of those two greater than 180, then I would reject that solution. All right, let's try another question. So the other question says, find the measure of angle L in triangle KLM, given that angle LKM measures 52 degrees. So again, it's the same principle. I'm going to call this KLM, and I need to find the measure of L, and I know that LKM measures 52 degrees. And one thing that I'm missing that I forgot to place in there is that LM is 158, so LM is 158, and the other one, KM, is going to be 128. So given the information that I have, I can say that the sine of 52 degrees divided by its opposite side, which is 158, should have the same ratio as the sine of angle L divided by its opposite side, which is 128. So again, now rearranging the formula, it would just be 128 sine of 52, all divided by 158, should equal the sine of L. So I would just go into my calculator and I will say 128 times the sine of 52, and then I will divide that by another 158, and I'll get 0.6383, 0.6383, and that will equal the sine of L. Now, to figure out what the value of angle L is, I'll say that this is going to be the sine inverse of 0.6383, which is equal to L. So again, with the calculator, I will go to second function, sine. Now, because the digits that were in there were these above, I'll do second function answer again, and the answer turns out to be 39.7. So angle L is 39.7. Now, as an acute angle, now if I were to do the obtuse angle that corresponds to that, I would have to do 180 minus 39.7. So when I take out my calculator, 180 minus 39.7, that gives me 140.3. So that tells me that the two angles that would fit into triangle KLM would be either the angle of 39.7, so here's the angle, 39.7, or I'll take 180 minus that angle to tell me what the obtuse angle version is, which is 140.3. Okay. Now, the last thing I have to do in the problem is I have to decide whether I'm going to accept or reject this angle of 140.3. So how do I do that? What I do is I take the angle 140.3, which is my obtuse angle, and I add it on to the other angle that's in the triangle. If the sum of these two angles is larger than 180 degrees, well then that simply means that this triangle cannot exist. It does not exist because the sum of two angles cannot be greater than 180 already. In order to make a triangle, I have to have the sum of three sides. Okay? The sum of three angles that equal 180. And if only two angles added up are adding to 180, then that means a triangle can't be built because triangles can't be made just out of two sides. You need a third side and a third angle. So because 140 in this case that we found by taking the acute angle 39.7, we subtract it from 180 and we get the obtuse angle version as 140.3. Now when I add the 140.3 to 52, I'm getting an answer that's way over 180, and therefore all I have to say is no solution on this. There's no solution because there is no triangle that could ever be made by using just two angle measures that add up to a number over 180 degrees. So therefore, all you need to say is we reject 140.3 as an angle since 140.3 plus 52 is greater than 180 degrees. All right. So I'm going to stop you right here because we're going to talk the next time about some of the other things. You are responsible for completing exercise 10F, numbers 1 through to 4, or rather, all of it. Okay, I'll see you guys next time.